You even got a camera for this.
Yeah. Hey everyone, welcome back to my workbench. We have a special guest tonight. This is my son Glenn.
Hello.
So he is building like a Mars rover except for Earth.
Mm-hmm. It's meant to be self-sustaining. Basically, it moves during the day when it has solar panel, and then it kind of goes into not shutdown mode, but low power mode during the night and just observes stuff. So you just have a significant enough battery supply to last the night.
Nice. So it's going to be powered up with a Raspberry Pi, and right now we're putting together these are some salvaged 18650 cells. So I wanted to do two things. I wanted to make a little impromptu pack here because they're planning to use how you specify a lithium pack is you'll see like a 2P, 2S, which means 2 in parallel, 2 in series. But in this case, they're going with a 4S, which is 4 in series system, so they can get 14 volts. Because when you're running higher voltage, it gives you an advantage of you don't need as thick wiring to do all of it. How do I want to pack these together? Package these. Positive, negative. Flip you around. Okay. Maybe we do a little bundle like this.
I might want to get higher capacity ones.
Yeah, this is more of a proof of concept because these are little.
Hook it up to the solar charger.
I think these are like 3,400 milliamp hours. Very similar to ones I already use, but everything I've done so far hasn't really been super high capacity.
For what we're testing, we don't need more. We just need the 14 volts.
Yeah, we want to see the 14 volts because they're nominally 3.7 volts per cell.
Mine 4.8 because they're all in series and the diameter stays the same.
Well, that's a really crappy tape job there. Yeah, that's terrible. I'm very self-deprecating on this channel, so I try to. I don't have a cool British accent or anything. I just
work with what you got.
Work with what you got.
Oh, that looks nice.
Yeah, that's a better wrap there. That looks like a bundle of TNT or something. All right. So
if you're stupid enough, it could be.
Yeah, don't puncture these cells, especially the little flat ones. Those are the worst. So let's see what voltage have we got on here. Let's go real nerdy and use the scope probe instead. .27 volts. Let's see what's holding that. Oh, 4.1. That's a full charge. Even though they're rated 3.7,
they go a little over.
They go a little over when they're fully charged. 4.1.
Yeah, I know.
Yeah, right here by the F2 key.
I see it. Yeah.
Yeah.
Yeah, when we found some borrowed ones, like a 14.8 series one.
4.1. Oh,
they always go up.
These are nice and solid. These are fully charged. I didn't know it was 100% state of charge. 4.1. That means they're balanced too. That's good. You always want your cells, like industrially, like in the big vehicle packs. The max cell voltage is 15 millivolts across the entire. Yeah, they all need to be very similar voltage each cell.
What happens if they aren't again?
One will start discharging the other one, and vice versa. So the big problem is if you have like a shorted cell. Then there's a bunch of current will flow through it, it'll heat up, and it'll eventually explode. Okay, so we have new tools tonight. This is exciting. So this is low temperature solder paste. Melting point 183 C. C? C. Alright, so this is 183 C. Alright, and then we have another new tool. This is a hot air tool. Lots of them have like a base, but this one is all in one. I'll show you. This is the first time I'm using this. So hopefully it doesn't blow up. Alright, so this is solder paste. Solder paste is used for surface mount electronics all the time. It's low temperature.
Because solder ones are easy to break?
Well, no, it's because when you're doing machine soldering, what they do is they go through what's known as a reflow oven. So they put all this paste down, they stick all the components on there, and this stuff is sticky, and then they put it through the reflow oven, and it just melts. People have made reflow ovens out of toasters because it's cool. Let's see, 183 is what? Not that hot, but what, 305 or something? More or less, not very hot. So an ordinary toaster oven could actually work as a reflow oven. But I don't need a reflow oven because I have... Let's see if this works. See how thick this is. So this is solder paste. It comes in the syringe. Oh good, it's coming up.
You want to use low heat for the batteries.
Correct. I didn't want to overheat because the problem is when you're using regular solder, we're up at 580, 590. I don't want to go that hot. Ooh, this stuff is thick. Ah, there it is. See? Oh, that's solder paste. I'll put a little gloop. Oh, this one still has. Let me do a little cleanup here. I actually bought this because my Atari Lynx stopped working on, and I wanted to rework it, but there's a few surface mounts, so it's a lot easier to work with, because even back in the 90s they were already doing solder paste for surface mount. Put a little bit of this. Yeah, on there, you little bugger. Alright, this stuff here is pure nickel. This is for bussing stuff together. Alright, so this is our tool. So we'll turn it on. It's set to 264. There's a little fan inside. Isn't that neat? You can see heating up.
I like the ones that show you the actual heat now.
Oh yeah. Smells like victory. Alright, where are we at? It's nice because this one also has, the reason I got this crazy looking one, because you can also, the fan's built into it, so you can change how much airflow. The problem is if you have too much airflow, it'll actually float. As the solder melts, the components are kind of like squishing around. Though you actually push components off the board. Let's see here. Let's see if we get a good reflow or not. Come on, baby, you can flow. Let me see. More heat. Let's get it up to 300 with a little more wind. Really? Let's see. What's the reflow temperature here? Like I said, this is the very first time I've tried this. See if I can get a reflow on this. Part of the problem might be it's such a big surface. Oh, it's hot. Ow! That's really hot. All right. Well, let's do it the old-fashioned way. You'll notice heat guns, when you turn them off, they should stay on for a while because it's cooling off the heating element. So don't worry if you buy one of these things and it keeps going, it's supposed to keep going. Now what that means,
Oh, so the fan keeps going to cool the heat.
it cools the heat so it'll last longer. It'll turn off once it's done cooling. Well, let's see if we can do this ye old-fashioned way.
Good old solder hand.
And flux, Radio Shack.
And how long have we been using that?
since at least 1997.
So
Oh,
older than me.
no, this one's newer. I take it back. This logo is from like 2005 or so.
Probably still older than me.
Oh, I'm sure it's older than you. We'll put a little flux on here. The reason you put flux on is so the solder flows better. So,
Instead of, yeah, you do the flux first, and then
yeah.
there's the solder flux combo.
So now, how we're going to do this is we're going to wire this up in series. So we're going to come, this will be our, we'll call this our positive, and this will be our negative. So it's going to go positive, then we're going to flip it over, go from the positive to the negative, then it's going to come back up positive. It's negatives. Positive. Let me do this right. Positive to the negative. Negative to the positive, positive to negative, negative, positive, positive, negative, negative, positive, positive, negative. Okay, we're good. We're not going to blow anything up. So, long story short, this positive and this negative need to be bussed together. So we'll use a little bit of this bussing stuff here. Let's see if we can get some solder on there first. I'm not going to have my iron crazy hot. Turn that down a little bit. Like I've always said, get a digital iron with digital temperature control. Because the ones without...
The first soldering iron I did with my teacher was it just had power 1, 2, 3, 4, 5. And like 5 was too hot, 4 was didn't work.
Like I said, always use...
Yeah, whatever this one is called, it's fairly inexpensive, but it seems really, really good.
Oh yeah, it's like a $60 iron or $70,
For
but
digital temperature.
yeah, I really like it. So what I'm going to do, watch what I'm doing here. So I'm putting getting a little bit of solder on the tip of
Itself?
itself, because if your tip is dry, you won't get any heat conducting through it. So now that I put it on top, I'm actually going to apply heat to the back side of it here.
And that'll go through.
It'll go through, theoretically. I don't want to hold a 500 degree. Yeah. It's actually not too bad, I can feel it. No, it's on there. Let's see. Looks terrible just because I have there's a tab of remaining crap on there. If this was a brand new cell, it'll be a lot easier. So I'm just going to pack a little more solder.
Doesn't need to be perfect.
No, because this is more proof of concept than anything else.
We just want to make sure everything works together.
Yeah, so you already bought well, you were gifted lack of a better term, gifted a pretty damn big solar panel.
50 watts.
A 50 watt panel is pretty big.
Normal voltage is 18 watts, 3 amps.
That's a pretty beefy...
I know. We measured it outside with the rest of my friends. It was pretty cloudy out, and I think it was like 4 p.m., and we still were pulling, 5 volts, and it was going in between like 0.5 amps and 0.4, which is actually pretty decent.
Yeah.
For that time of day, and especially with the cloud cover.
Yep.
But most of the time, it's 10 a.m. to 2 p.m. is going to be the majority of our...
Yeah. You can even write an algorithm so
Exactly.
you have your panel slightly tilted and have it face south to get your maximum.
I had this crazy idea where we'd actually have it elevate and rotate itself on top.
Yeah.
That'll be the next rover.
Yeah,
That's a bit too complicated for now.
Give me some heat. Come on, baby. Takes a lot of heat to do this.
I thought we were going around for the first one.
No. This will be our ending part. And then we're going to flip it over and do 2 more bus bars in the back.
Alright.
Let's see how well this is on. Don't try this at home, kids. Don't try that, Glenn. I won't. Thanks. Put this away for now because it's not doing what it's going to be good for what I need it for, but it wasn't great for this task. Good. I'm getting choked here. Oh. deafen the audience with the lavalier mic. Hello. Okay, so that bar is actually.
Can I see?
Go ahead.
So that's positive, that's negative. So what we're doing is positive, negative.
Now we're going to have to flip her over.
We're going to flip it over to this side so that this, I see.
Yeah.
And then we'll have, at the end, we'll do it where it flips over. Oh, wait, no, it goes through the back. Yeah.
Yeah, we don't need, the top basically, we can more or less tack wires onto this side.
Oh, yeah, because what we're going to, I see.
You're going to need 2 wires that go out to your.
So it'll go bink, bink, and then we'll go, yeah.
Bink, bink.
Mm-hmm.
So,
and then it goes through that.
yeah, so this is our positive, so we need to go for the negative in this one, the positive in this one. So let's start with that. Flux. Everything's in flux. Nice and gooey. Alright. A little piece of this.
You're using flux at the start because you don't want to solder directly onto the battery at the first.
Well, not just that, is because otherwise I'd have to apply way too much heat to it to get the solder to flow. Because I don't know how this surface is conditioned yet, so
the flux helps.
When in doubt, throw some flux on there.
We don't want to risk it with a lithium ion battery.
Correct. And maybe you can even, what I often do is I put flux on there, and then we can we'll put some solder on there. You'll see the poofs of smoke. Here we go. A little more solder. But the smoke is just the flux doing its job. As it burns, it's chemically it's kind of like blowing off. It's taking the surface impurities off with it, so it can get a nice good solder flow. So I need a little bit of solder on the tip here. This is not the most elegant way to do this, but at this point we're just, like I said, we're just proof of concepting it. There we go. All right. I'll come over a little bit, I think. Talking to myself now. Okay, let's go here. This thing's a little too. I guess use my flush cutters to get this thing off.
That's what those things are called.
Yeah. These are flush cutters, and these are called diagonal cutters. See how the wedge is like a diagonal wedge?
And the flusher. Well,
flush. See, it's a flush surface.
Yeah.
So diagonal flush.
I prefer flush cutters.
I prefer flush cutters too. The only problem is when other people use your tools, they tend to wreck your flush cutters because they use them for stuff they really shouldn't be used for. You're not supposed to cut through thick wires with flush cutters.
No. I usually use flush wires for like zip ties.
Yeah, it's perfect for that. Let me see if I can cut these tabs flush. That's why you have a flush cutter, so you can cut them flush. There we go. Ooh, that stuff's sticky. Alright.
I like how it looks like a bundle of TNT.
Yeah, so we're going to go, this is the positive, the negative, to the positive. So let's try this again. Throw some more solder on. Screw it. More heat. These cells should be alright. I'll measure the voltage of them after we're done. Just make sure we didn't pop any.
Oh, we can measure the whole voltage too.
Exactly.
Because they're all in series. They were all at 4.1, right?
They're all 4.1, so we'll be at 4 times 4, close to 16 volts,
Yeah.
over 16.
16.4-ish.
There we go. Oh, this is not my most beautiful work. I'm very hard on my own soldering. I always have been. I'm very critical of my own solder work. I shouldn't be, but I am. Don't want to burn myself, that's the problem. We're at 616 degrees. Luckily, this stuff actually cools off pretty fast because there's not a lot of actual mass there.
Mm-hmm.
I bought this specifically for making lithium packs.
Can I look at it again?
Go right ahead. Neat, huh?
Yeah. So then we're going positive to negative, and then on this side again. That's
Doing this, yeah, exactly. So these are just staying what they are,
Mm-hmm.
and then these guys here will be bust just like that. So we're going to go positive, negative, positive, negative, positive, negative, positive, negative. So yeah, gets us back to where we started. And that'll give us a 4S 1P. 4 series, 1 parallel. And the neat thing is, once you can have like multiples of these, you can go put a bunch of them parallel. If you need more power, you just keep your 4S arrangement, just put more in parallel.
So we just make one more of those if we want 4S 2P.
Correct.
Which is what we're going to do in the actual rover, because that, with the ones we want to buy, give us the good ampage and the correct amount of volts.
Yep. Yeah, so you found that charger. It's actually really neat because it auto detects if it's lithium or lead acids.
Yeah, there was a one that I looked pretty good, but it only did lead acid.
Yeah.
Also, I like this one because it comes in 20 amps. They have two versions. The small one is either 10 or 20, and then there's the big 30-40.
Yep.
And our control hub, which we're stealing,
borrowing.
Yeah. Well,
are you going to return? Well, if it's garbage, then
no one even uses it because 2 of the motor ports are busted. 2 out of 4, but we only need 2 motor ports anyway.
Yeah.
But we're using it, and it only handles 20 amps most. So I got the 20 amp solar charger, and which helps with keeping weight and size down.
Yep. So, take a look. Isn't it?
Yeah. I see. So.
Yep. And now we can just do real quick.
You just put 2 wires on.
They always put a little notch right there that always tells you if you lose all your other indications, the notch is always the positive side. So we're gonna.
Yeah, because these are flush heads.
Yeah.
Ooh, that's 16.56.
Yeah. Very good.
Perfect.
So I didn't damage it.
No, not at all.
Not this time.
I actually gained 1.6.
Yes. We added a little power to the system. Though I don't know how good the calibration is on this old thing. I'm sure my scope is more accurate.
Let's do the scope then.
Yeah, let's see what the scope says. Scope. What's my vertical on my scope? 5 volts of division. Let's see. 5 volts of division. Let's do a 10x probe, just so I don't blow it up. .9 volts. Let's do. Let's go back to 1x. Let's see what she says.
Oh, 16.4.
16.4. Dead on. Well, it's
That's how the math works.
Like I said, I know this scope's a lot newer, so that's gonna be more accurate. So tomorrow, actually, you want to throw some wires on there?
Yeah.
Let's see if we can find some wire. You want some thicker wire. Let me pause the video real quick and go find. All right, so I scrounged some wire. We'll just throw some wire leads on here so we can. Where's my stripper? Let's guess this is. Let's start with 22. No, this is 28. As always, it's inverse, so the higher the number, the thinner the wire.
Mm-hmm.
Yeah, there's actually a whole, like, ratings of different gauge wires for how much they can handle AC and DC. This is 28 gauge. This should handle, I think, 4.
So it's just like a shotgun. The lower the gauge, the bigger it is.
Yeah, it's the exact same concept. It's always a 1 over.
Mm.
I love 1 over in electronics. And everything. Everyone loves a 1 over for some reason. Alright.
What is 1 over again?
It's a 1/28th or 1.
Oh.
Yeah.
So it ends up being inverse.
Yep. So that's why you're... Oh, this is ugly as hell, but who cares? Alright. I'm so hard on myself with soldering. I don't know why.
I don't even think the camera's that super high definition.
Well, sometimes I get really close. I have a microscope down there, too. It's cool. It's digital. Yeah, there's some ugly-ass solder work. Oh, well. The only thing we have to be careful of is this now has 16 volts on it. So if this shorts, these batteries will want to kick out a lot of current. And you'll get melty. So what we're going to do now is tape it up. And move along here. I just want to cover these exposed bits. Kapton, this is stuff that's called Kapton tape. It's for high temperature. It's like electrical tape, except you can go 600, 700, 800 degrees with it, easy.
So it's like better electrical tape.
Way better electrical. That's why NASA uses it. You'll see this in aerospace all the time. And a lot of electronics, you'll see Kapton all over the place. That's what this weird orange wire is.
I always wondered what that is.
Yep, Kapton.
What does Kapton stand for?
It's a brand name. It's like Kleenex. It's a... I forget who came up with it.
I ask because we love our acronyms here in America.
No, it doesn't. It's just a brand name. It's, yeah. Yeah. So, whenever we want to try it, we can hook it up. Actually, oh no, it's going to need the battery and the solar. We'll work with just the battery.
We have the solar. We have the
Grab this, the
solar.
just the controller for now.
Yeah, solar controller. Got it.
Yeah, let's see if it even fires up. It might. Run just... Oop, watch your knees.
Yeah.
Alright, so this is the solar charger, PWM. PWM stands for pulse width modulation. Let's take a look at it. So, 20 amps. Wow, it can take up to 100 volts in.
I know.
That's crazy. It's neat. It's got 4 USB ports. So input power, so we're going to be around 12 volts. So it'll be 260 watts. That's a lot of watts. So let's see. It might just turn on as soon as we put the battery on there. Always connect negative first.
Why?
It's safer.
Why?
Because if you have an issue, you want it to flow. Because if you hook to the positive first and you have a connection to ground somewhere that's not intended, stuff will do weird things. It's not good. Screwdriver. So these, watch this one, and audience. So how these work is you screw it down, and it'll doing a YouTube video. Actually, they need to open it up first. See, I'm turning it. Opens up. See in there, Glenn? Just put your little wire in there. Look, we have even more visitors. This is Tiffany, and this is Ricky. Hey there, Ricky.
Richard.
Lucy.
His YouTube premiere.
Well, he's already premiered.
Oh,
Lucy
he's
has.
premiered.
Yeah, Lucy hasn't been premiered.
We'll do both chat.
Here it is.
He's a little baby.
He's a good boy. Oh, got the whole family here. Where's Lucy? Thank you, Ricky. You smell like dog food.
No.
He's a good boy. Alrighty, let's try this. Yes, like I was saying, if you hook up the positive first, if you have a bad like connection to the ground, like this tabletop here is actually connected to the ground. It's high resistance, but it's still connected to the ground. So unscrew this, open it up, put it in, tighten it down. It powered up right away. I can see it. E12. It's sad because there's no solar panel.
Oh.
Oh, there it goes. Now it's happy. I recognize it. 16.4. Oh wow, look, it actually read correctly.
Yeah. So E12 I think is the mode it's in because it can be in rated voltage mode.
Oh, yeah.
24, 36, 48.
Yeah, yeah.
Ooh, it actually tells you 1.7 volts.
That's it?
Or is it? It says 1.7 volts.
No, 23C.
Oh.
That's the whole pack. So
Where's that amps? It said.
No. 16.4 volts. Huh.
Yeah, if you... I must have seen something.
Oh, it's recognizing it. It's just waiting for power to come in, which means
it works with lithium ion.
it works with lithium ion. You know, for giggles, let's grab... Oh, I don't know what's loaded on this Pi right now. You want to try an experiment?
Yes. I want to just first, I want to know how do you change how it's rated voltage.
It just picks it up automatically.
Oh, but like the output voltage is.
Oh, I don't know how it does the output voltage. Oh no, E12. It probably means it's 12 volt output. Oh, okay.
The 5 volt ones are in the front here.
Correct.
So that's what we'd hope
Oh, let's measure it real quick. What's it outputting on the? Let's see if it's doing that. Silly scope.
It says lithium battery user defined.
Huh.
But it's recognizing it.
Yeah, let's see. 6 volts out. Well, that's interesting. Oh, wait. We're in the wrong mode. 16 volts. Alright. 16.4 and 6.13. I'm sure there's an instruction manual in there.
No, there isn't, but there is on the work button.
Oh, careful.
Yeah.
Okay, I think that'll be it for the YouTube video tonight. So everyone, thank you for watching. Thanks for everyone with your support, because the last video I did, Glenn, was for talking about Mom's cancer. So
Yeah.
so everyone's been really supportive. So thank you, Clint, and I think Josh, and I can't remember who else. Previous customers of mine. It's great. But everyone, thank you for watching and your support. And now we're going to figure this out.